All right, so here we have the definition of mutually independent and events. Okay, uh, let me remark the following. So let n equals 3 and assume that a1, a2, and a3 are mutually independent. Okay. The screen. Then, of course, by the definition, then we have the following conditions. Uh, PAI is equal to PAI. Of course, these are trivially true. PAI intersection AJ is PAI times PAJ. This is true for since the events are mutually independent. Similarly, this is also true by the same reason. So the probability of the intersection of three events is just the product of the probabilities, right? Well, just note that these equations, these are all real numbers, right? Some real numbers. Uh, so we have some equations in real numbers. Note that the equations above are all independent. What do we mean? In the sense that none of them can be derived from the rest. Okay, so there are three equations here. They are trivially true, and then three more equations here, and one more equation here. So we have 7 equations, and if you take one of them, you cannot get that equation as a result of the remaining 6 ones. Okay, so that's what we mean by saying that they are independent equations. Böyle bir şey oluyor. Yere değiyor herhalde. Hı, evet. Okay. Here is another proposition. The events A1, A2, AN are mutually independent independent if and only if this probability A1 alpha 1 intersection AN alpha n is equal to the probability of A1 alpha 1 times A2 alpha 2 times the probability of AN alpha n for where AI, AI alpha I is either AI or AI complement for each I from 1 up to n. So we had similar statement for the intersection or for two independent events, right? Where was it? So it was this one. Yeah. If you have two independent events, then this three pairs of events are also independent. So this is just generalization of that statement to n events. Okay. Uh, here is okay. So proof of this is proof is left as an exercise. It is similar to what we have done above. Okay. Yani iki tane yerine n tane var. Başka bir şey değil. Here is a remark. Now let C be a collection of events, finite collection of events, AN, be a finite collection of events so that the intersection of all these events is empty. Okay. Assume that each probability AI, PAI is positive. Okay. Then the collection C is not a collection of mutually independent events. Because, why is that? Well, if it were the case, right, we would have 0, which is A1 intersection A2 intersection AN, right? By assumption, this intersection is empty and the probability of the empty event is 0. But if they were mutually independent, this probability would be the product of these events, right? PAN, but by assumption, all of them are positive numbers, and product of positive numbers is, of course, positive. So we have 0 equals a positive number, a contradiction, a clear contradiction. So this is an interesting observation, right? If you have any finite collection with where each event has positive probability, and if the intersection is empty, then they cannot be independent. So it is like, if today is Monday, uh, it cannot be, right, Tuesday, right? So the event that, today is Monday and today is Tuesday are dependent events, right? They are not independent. Right? Let AI be the event of today is Monday, A1 is Monday, A2 is Tuesday, A3 is Thursday, Wednesday, and so on. 7 events. The intersection is empty, right? But each one has probability 1 over 7, and the product is 1 over 7 to the power 7, I guess. And these events, of course, are not independent. Bilgisayar bir şekilde bu haberleri okumamızı istiyor herhalde. Yani bir yere dokunmadım bile. Hazırlamak istemiyoruz. Okay. Okay. Here is another definition. The events, let's say A1, A2, AN, are said to be pairwise independent if each pair of events, let's say AI and AJ, are independent for any IJ. Okay, so you have an event. We define pairwise independence. What's that? You just take any two of them and they have to be independent. And this should hold for any pair of distinct events. Okay, if this is the case, we call that set pairwise independent events, not mutually. We will see that in a minute that these two definitions are, or concepts are, different. Okay, so remark, biraz kafa karıştırıcı bu ama gerçekler böyle. Pairwise independence doesn't imply mutual independence. Right. İnsan bir ara şey düşünüyor, yani ikili independentlarsa, değil mi? Hepsi independent'tır diye. Ama öyle değil. Let's consider the following example. So our sample space is this set 1, 0, 1 and 1, 1, 0, and define the events. Define the events. So this is like tossing a coin, right? Or 3 coins, or tossing a coin 3 times, and you have this sample space, but you don't consider all the possibilities, just only 4 of them, and we define the following events. A is the event, the first digit is 0. B is the event, the second digit is 0. And C is the event, the third digit is 0. Okay. Then, of course, let's compute. Then we have all these probabilities. What is PA? First digit is 0. What is the probability of this? It is 1 over 2 because we have 4 elements and only 2 of them has 0 in the first digit. So this is 2 over 4, which is 1 over 2. What about PB? The second digit is 0. Well, that's also 1 over 2. And PC is third digit is 0. It's also 1 over 2. Okay. What about PA intersection B? Well, again, these are all the same. This is the probability that the first and the second digits are 0. So it is only 1. And this is second and third digits are 0. It is only again this one. Yes, so these are all 1 over 4. Evet. Onda da 2 tane var, değil mi? Ee, Diğer yandan şu da doğru. What is P A P B? So I already computed these probabilities. This is just 1 over 4. What about P A P C? This is 1 over 4. And P B P C, this is again 1 over 4 because each one has probability 1 over 2. Therefore, hence, these events are pairwise independent. Okay, are pairwise independent. A and B are independent, A and C are independent, and B and C are independent. What about mutual independence? Well, we have to check one more probability, that the probability of A intersection B intersection C. What is this? Well, this is the probability of having 0 in the first, second, and third digit. Well, there's no such. No, okay, yeah, there's only one element. So this is 1 over 4. 1 over 4. Oh, pardon. Sorry. I'm considering this C complement. Sorry. This means the first and the second are 0. The third digit is 1. First two digits are 0. The third digit is 1. Well, there is no such element. So this probability is 0. And that's not equal to 1 over 8, which is the probability of PA times PB times PC. Right? Each one PC complement. PC is 1 over 2, therefore PC complement is also 1 over 2 because, C and C complement gives the whole space. Each one is 1 over 2, so this product is 1 over 8 and that's not 0. so that A, B, and C complement are not mutually independent. Evet, evet o da olurdu. Haklısın. Tamam mı? Yani bilmiyorum siz nasıl karşılıyorsunuz ama bence bu biraz ilginç bir şey. Right, this is something interesting, right? I mean, frankly, I would think at first that if they are pairwise independent, then uh, they would be mutually independent, but it is not. So it is interesting. Okay, here is another definition. Let A be an event. So let A have positive probability. Positive probability. And let P dot slash A be the conditional probability on A given A. Okay, so whenever you have an event, I just compute P, let's say that event given A. Okay, so this is another probability measure on the same sigma algebra, conditional probability. A class, let's say like this, B1, B2, Bn in A, oops, in A is said to be conditionally mutually independent given A if it is mutually independent and with respect to the conditional probability. Mesela in particular, so a special case of this, let's see a special case, two events B and C are conditionally independent given A if what happens if we have the independence equation for the probability P given A. So we have this probability of B and B intersection C given A should be the probability of B given A times the probability C given A. Okay, note that in this case we have the following. Of course, what is this? The right hand side is just P B intersection C intersection A divided by PA, right? And this is equal to P B A times PCA, so that P of A B C, so this probability here is equal to PA times PB given A times PC given A, where yok tamam böyle. Bir remark daha var. Onu da yazayım. Note that C given A intersection B. What is this? So probability of C given A intersection B. So this is just by definition the probability of C intersection A intersection B divided by P of A intersection B. But this is equal to just P A B C. Instead of P of A intersection B, I can write P of A times P of B given A, right? Because by definition, this is just P B given A is the ratio of P of A intersection B divided by P of A. I just wrote that. And thus we have the following. P of A intersection B intersection C is what? PA times PBA times PCA intersection B. Okay. Here is an exercise using induction. Prove that. Bunu ispat edebilirsiniz. Yani bunun geneli. So PA1 intersection A2 intersection A K is equal to PA1 PA2 A1, and you multiply all these up to PAK A1 intersection A2 A K minus 1. So each time you put another set to the right hand side, you take intersection with one more event. Okay, so, and you have this formula. Yani şunun genel hali, değil mi? Okay. All right. So B and C are, so two events are independent given A, if and only if and only if uh, P C given A and B. Ee, Bunu tarif ettik mi biz? Kafam karıştı. Bir dakika. Ha, şey demekti değil mi bu? Hem yani so this means both A and B are given. We okay. So probability of C given A and B. This is equal to P C A where we assume that the defining probabilities are positive. Yeah, just let us think about, for example, this equation here. P of C given A and B is equal to P C given A. So here, what is the difference between these two? I have B here and I don't have B here. In other words, this suggests that B and C are independent, right? Because it doesn't matter whether you assume B or not, the probability of C given A is the same, okay? Whether you assume B or not. And similarly, here again, it doesn't matter whether you assume C is given or not. The probability of B given A doesn't change whether C is given or not. Değil mi? Yani B'nin olasılığı A'ya göre değişebilir ama C'nin olup olmamasından bağımsız. Alright, now let's see the proof. This makes sense, but let's see the mathematical proof also. Bakalım. So what is the probability of B intersection C given A? Well, by definition, this is the intersection of B intersection C with A. So it is A, B, C divided by the probability of A. But what is this? Here we had this formula for ABC. This probability is the product of these three probabilities. So let me write it down. This is PA times PBA times PCAB divided by PA. Yes. Şurada yalnız ben yanlış yazmışım. Here we have to be okay. Yeah, here yani şu probability okay. So this is just a notation. Instead of this, I guess we can write P C given A and B. Right? This is just a notation. Yani A'la B'nin aynı anda olması bu demek. Just a notation. Okay. So we have this. So this is just P B given A times P C given A and B. So I have this equality. So if B and C are independent, given A, then of course we have this PBA times PCA. If B and C are independent given A, then this probability is the same as PB intersection C given A. Yes, so we have what? So that şimdi burası buna eşit. Bu da buna eşit. So this thing is equal to this and the same thing here is equal to this product. So this one and this one are the same, right? I have PBA. So PCA is equal to PCA comma B. So that PC given A is equal to PC given A comma B. Okay. Well, this is an if and only if statement, so we have to consider the other way around. Conversely, if PC given A is equal to C given A and B, then going backwards, we see that yani bu işlemleri tersten giderseniz P of B intersection C given A is equal to P B given A and P C given A, so that B and C are independent given A. Okay. Uh, okay. Uh, the other statement is of course the same thing, right? So I have two statements, but so the other statement is proved similarly. Neydi o? So the second statement is this, but you know they are the same basically. Okay. There is another definition. A finite collection. A finite collection. Let's say of sigma algebras, not events, but sigma algebras. But they are actually sub sigma algebras of another sigma algebra A is said to be mutually independent uh, here with respect to a probability P on the on the big sigma algebra A. If what happens, if the following happens, if I have AI is the product of for all AI from the subalgebra AI. So we defined about the independence, mutual independence of n distinct elements. Here we have subalgebras. We will say that these subalgebras are mutually independent. If what happens? If you choose arbitrary elements from events from these algebras, and if they are mutually independent. Okay, so you just pick random elements from each subalgebra. If they are mutually independent, then we will say that the algebras are mutually independent. Okay, so this should hold for all choices of uh, events AI from the subalgebra AI. Okay. Uh, the continuation of this definition is the following. One can uh, extend this definition to infinite families. An infinite family of sub sigma algebras of A is said to be independent if every finite sub family is independent. Okay. So you may have infinitely many subalgebra, okay, not just finite. But whenever you pick finitely many of them, if they are independent, then we say that the whole algebra is independent. Sorry, the collection of all these subalgebras are independent. Okay. This is like, independence of vectors, right? If you have infinitely many vectors, not just finitely many, how would you call whether they are independent or not? They are independent if whenever you pick finitely many of them, they should be independent, okay? You can check independence, linear independence of finitely many vectors. And if for any choice of vectors from that set, if you get an independent set of vectors, then you can say that the whole family is linearly independent. So this is, analogous to that actually concept. Yani algebralar sonsuz tane olabilir ama siz onlardan ne zaman sonlu tanesini seçseniz onlar independent olacak. O zaman bütün e, algebraların koleksiyonuna independent diyoruz. Any questions? Evet. Pairwise independence. Aha. Nedir sorun? Bir saniye, bu arada şey söyleyeyim de isterseniz çıkabilirsiniz. Ders bitti. Bir daha söyle. Aha. Şu anda açtığım örnekten mi bahsediyorsun? Ha, anladım. Yok ama şöyle düşün. Burada iki farklı şey var. İlk önce bu pairwise independence'ı gösteriyorum. E, O şu. Yani A ile B pairwise independent, A ile C pairwise independent, B ile C pairwise independent. Üçünün mutually independent olmasıysa şu. E, Yani zaten şunu biliyoruz. ABC olaylarının independent olması için şey gerekiyor. Ee, Aslında belki şöyle demek lazım burada. Evet. ABC are not mutually independent. Çünkü şurada yaptığımız şey burada yapmamış mıydık onu? Pardon. Şu. Yani bunların independent olması için bu probability'nin şu çarpıma eşit olması lazım. Burada yani A'leri de alabilirim, komplementleri de alabilirim. Değil mi? Yani A1'den A'nın mutual independent olması için bütün bunların birbirine eşit olması lazım. Burada bu proposition aslında kullanıyoruz. Ee, Şimdi bu anladın mı? Tamam, yani şunu görüşürüz. Pardon, şunu düzelteyim de sonra böyle eksik kalıyor. Sor. Aha. Anladım. Yani algebranın tamamını alsaydık diyorsun, bu olmayacaktı gibi. Ee, Yani bu örnekte öyle olabilir ama yani bu şeyi gösteriyor işte, ama hani nasıl diyeyim, hani rastgele bir algebrada bu iki konsept birbirinden farklı. Ee, e, z- Zannetmiyorum ya. Daha sonraki derste bununla ilgili biraz daha derinlemesine şey yapacağız. Şu anda tam hatırlamıyorum her şeyi de. O zaman belli olur o.